Okay, I just want to get some practice with integrating both definite integrals and indefinite integrals. So throughout this video, I'm going to be interspersing the two sorts of problems. A lot of the skills involved are the same. We're going to be finding antiderivatives, but if it's a definite integral, you're then evaluating that and subtracting to get a number, whereas if it's an indefinite integral, you're adding c to get a family of functions. Okay. So I'm going to suggest that you pause the video. You'll probably want to rewrite some of these terms to make the finding an antiderivative part a little bit easier. See if you can work this through and then tune back in and we'll work through it together. Welcome back. I'm going to rewrite this piece as a fractional power. I'm going to just observe that that piece is 3 copies of 1 over x. That's the 1 power, remember, where the power rule is not helpful because this is x to the negative 1. If I raise that by 1, I'll get 0, which we can't have in the denominator. But it's kind of helpful to see that that's just a constant multiple of my reciprocal function. This I'm going to rewrite as 5x to the negative 2, and then plus 2 dx. So now I'm ready to go through and take an antiderivative, and I can just do that one term at a time when these pieces are connected with addition and subtraction. So here I'm going to get 2. I'm going to raise the power by 1, so I'll get x to the 3/2. Divide by the new power means I'm going to multiply by 2/3. Minus 3 times the natural log of the absolute value of x. Now, you might notice that for this problem, we're only working with x values between 1 and 4. So all my x values are positive, which means the absolute value of x is going to be the same as x. The problem is, if you don't write that absolute value, I can't tell the difference between you forgetting that you're supposed to write the absolute value and you thinking, I'm working on an interval of positive x values, so the absolute value of x will be the same as x. So, you have 2 choices. You can write the absolute value, I think that's the simpler choice, or you can write me a note. Dear Carla, I notice that we are working with the interval from 1 to 4, on which all x values will be positive. Thus, for this problem, the absolute value of x is the same as x. That is why I did not write my absolute value signs. You'll get full credit then. Just takes a lot more time to write that than to write the absolute value. Okay. All right, so plus 5 copies of power rule here. So I raise the power by 1, so I get x to the negative 1. Divide by the new power, that's the same as just multiplying by negative 1. Okay. And then an antiderivative of 2 is 2x. Remember, if I have a constant, that's saying the derivative is constant. That's like saying the slope is constant. I'm getting a line of slope 2. So there's my antiderivative, and we're evaluating that between 4 and 1. Now, here, I took an antiderivative of the whole thing and then threw on the evaluation bar. If you prefer, you could have done that after each piece. So you could have written 4/3 x to the 3/2 evaluated between 4 and 1. Minus 3 natural log of the absolute value of x evaluated between 4 and 1. Minus 5 x to the negative 1 evaluated between 4 and 1, plus 2x evaluated between 4 and 1. This is equivalent. Okay. I usually just write it all out as one function. It's just a little bit less writing. I do need to be careful, though, then, because when I'm ready to evaluate it, I'm going to have to make sure that it's what I get at 4 minus what I get at 1. I've got to subtract this whole thing. So I usually will write my parentheses from the very beginning. Okay. So now, let's go through and plug in 4. So this is going to be 4/3 times 4 to the 3/2. Now, here's my rule for fractional exponents. The number on top tells me to cube. The number on bottom tells me which root to take. I'm taking a square root. If the root part is nice, you got to simplify it. If the root part is irrational, you can leave it as a fractional exponent. Square root of 4 is 2. 2 cubed is 8. So I can simplify that. So I'm going to write this instead as 4/3 times 8, which of course is going to simplify to just 32/3. Okay. All right, minus 3 natural log of 4. Now, here I'm plugging in 4 to the absolute value. In dropping the absolute value, I'm evaluating. I know that the absolute value of 4 is 4. So once I'm literally plugging in a positive number, it's no longer necessary to write that. But it's not super obvious at this point that x is positive. So you either have to point out that it is, or just write the absolute value. Okay. This is going to be minus 5 over 4, because that's over x, plus 8. Minus what I get when I plug in 1. 1 to any power is just 1, so that's 4/3. Minus 0, because the natural log of 1 is 0. Okay. Minus 5 over 1, which is just 5. And then plus 2. Okay. All right, so let's see what we've got here. This we said was just going to be 32/3 minus 3 ln 4 minus 5/4 plus 8. I'm going to just distribute this negative sign as I go through. So that's minus 4/3 minus a negative 5 is plus 5 and a minus 2. So let's see, looks like I've got thirds here and thirds here. So that's going to be 28/3 minus 3 ln 4. Let's see, minus 5/4 plus 8 minus 2 is going to be plus 6. And I can simplify that a little bit. Did I get everything? Did I do this? I think I dropped the 5. Sorry. So I had 8 plus 5 is 13, minus 2 would be plus 11. So I can simplify a little bit more because this, and this are just real numbers. So let's go ahead and get a common denominator for that. So it looks like we want a common denominator of 12, so I'll multiply this by 1 in the form of 4/4. So let's see, how many twelfths is that? What's 28 times 4? 2, 3, 112 minus 3 ln 4. This is going to become minus 15 twelfths plus 12 times 11 is 132. I know that. 132 twelfths. So we've got some twelfths minus, whoops, that was 3 ln 4. I accidentally wrote the 4 underneath the ln. Minus 3 ln 4. How many twelfths? So 112 plus 132 is 244 minus 15 is going to be 229 twelfths. Yeah. So that would be my final answer for that problem. Excellent. Okay, I'm going to put 2 more up. One's going to be a definite integral, and one's going to be an indefinite integral. So let's try the integral from 0 to 2 of x squared times x cubed plus 1 dx. And then let's try the indefinite integral of x squared plus 2x over x cubed dx. Now both of these have sort of the same issue. This one involves a multiplication problem for the integrand. This one involves a division problem for the integrand. We have not seen a nice rule for simplifying multiplication and division problems. So before you can do the calculus, you've got to do the arithmetic or the algebra. I guess it's algebra because we've got x's, not numbers. Okay. You've got to do the multiplication and simplify the integrand first. Do the division, simplify the integrand first. Okay. So go ahead and pause the video. Tune back in when you're ready to check your answer. Welcome back. I'm going to follow my own advice here and just distribute that. So that's going to become x to the 5th plus x squared dx. So that's going to become x to the 6th over 6 plus x cubed over 3, all evaluated between 2 and 0. So 2 to the 6th, that's 2 times 2 is 4, times 2 is 8, times 2 is 16 times 2 is 32, times 2 is 64. So I'm getting 64/6 plus 2 cubed is 8/3 minus, when I plug in 0 to both of those terms, I just get 0. This will reduce nicely to 32/3. So we've got 32 plus 8/3. That's just going to be 40/3. Excellent. All right, for this one, I need to distribute the division. So it's x squared over x cubed plus 2x over x cubed dx. So that's the integral of 1 over x plus 2 over x squared dx. I'm going to just rewrite that. I'll keep the 1 over x as is, but I'll rewrite this piece as 2x to the negative 2 so that I can use the power rule here. So then this would be the natural log of the absolute value of x plus 2 copies of x to the negative 1 divided by, which is for negative 1 the same as multiplying by negative 1, plus c. Don't forget, when it's an indefinite integral, you're finding a family of functions, so there's always going to be that plus c. So this is the natural log of the absolute value of x minus 2 over x, or I could keep that as 2x to the negative 1 plus c. All right, good stuff.